Okay, everybody, what we have here is a limiting reactants problem that I want to solve with you. So I'm just going to go ahead and start. When lead-2 nitrate reacts with sodium iodide, sodium nitrate and lead-2 iodide are formed. So we have to be able to identify these in the equation. Here is our lead-2 nitrate. Let me underline lead-2 nitrate, sodium iodide, lead-2 iodide, and sodium nitrate. So those are what those are. Now we have to make sure we balance that problem properly. And so if we stick a 2 as a coefficient here and a 2 there, my equation is properly balanced. So with the first question. If I start with 25 grams of lead-2 nitrate and 15 grams of sodium iodide, how many grams of sodium nitrate can be formed? Well, that's a limiting reactants problem. We have two A's here. There's one A, there's another A, and we have one B, which is our sodium nitrate. And so what we have to do is set up our problem as such. And we're going to start with our first one, and we'll start with 25 grams of lead-2 nitrate, PbNO3, 2. And we want to find out how many grams of sodium nitrate can be formed. And that would be sodium nitrate, NO3. All right, so anyway, following the flow chart, we have a few things to do. We have to, starting between 1 and 2, and what it tells us to do is put 1 mole of the lead-2 nitrate over the molar mass of it, which is 331.2 grams of it. And then the next thing we do between step 2 and 3 is we do a mole ratio. And moles of B over moles of A. Our first B is sodium nitrate. That's going to be a 2, so 2 moles. And then we're going to have our lead-2 nitrate, that's be 1 mole. We get all that from the equation itself. Last thing we have to do is we have to put the molar mass of the sodium nitrate, which is 84.99 grams, over 1 mole. Okay? When we solve for that, we get, I'm going to put that in a different color, 12.83 grams of sodium nitrate. Okay, so we'll put it in a box like that. Just hang on to that for a minute. Then we'll do our second equation, and we're going to work with 15 grams of sodium iodide. Shout out to Maddie in 5th period for this one. Okay, here we go. So we're trying to find the mass of our sodium nitrate again. We're going to determine what's being done here. It's a mass-to-mass problem, so following along the same steps here. 1 mole of sodium iodide over the molar mass of it, so it's 149.9 grams. And then next thing we do is a mole ratio from our equation, moles of B over moles of A. The moles of B is 2 moles, okay, from the equation. And moles of A, being our sodium iodide, is also 2 moles. And the last thing that we do is we put the mass of our sodium nitrate over 1 mole. And when we solve for all of that, we end up with 8.51 grams of that. Okay, now that makes, if you look at those two numbers, 12.83 and 8.51, that makes the sodium iodide our limiting reactant. We can't form any more than 8.51 grams of sodium nitrate. So the sodium iodide is the limiting reactant here. So I'm going to go to my equation and put limiting reactant here, and that means this is going to be in excess. That means more than what we need. We're going to calculate how much we need, and then we're going to calculate how much we went over, or what we didn't use. So the limiting reagent in this problem is the sodium iodide. Okay, next question is how many grams of lead iodide are formed? So now that we know what our limiting reactant is, or reagent, we use this for all remaining problems. Remaining problems. Okay, so if we use this for all remaining problems, we'll start off with our 15 grams of NaI. Try to find out the mass of lead-2 iodide. Okay? All right. Mass-to-mass problem again. And so we have 1 mole of NaI over its molar mass, 149.89 grams. And the molar ratio, 1 mole of PbI2 over 2 moles of NaI. Okay. Last thing to do is the mass of the PbI2. That's going to be 461.01 over 1 mole of it. And when we solve all those together, we get a mass of 23.06 grams of PbI2. So what was formed so far in this problem was 8.51 grams of NaNO3. That's as much as we can make, or what has been formed, and 23.06 grams of lead-2 iodide. Okay, so now we have to figure out how much of the non-limiting reagent, that's also called the excess here. And so what we need to do is we need to start with our limiting reactant again, which is 15 grams of sodium iodide. We're going to find out the mass of the PbNO3 that we need. What do we need? So it's going to be the mass of PbNO3 2. Okay, mass to mass problem yet again. So 1 mole of the NaI over its molar mass, which is 149.89 grams. Just put a G up there also. And then mole ratio of the lead-2 nitrate, which is a 1 over the coefficient for the NaI, and that's going to be a 2. Okay. Then we have the molar mass of the PbNO3 which is 331.2 grams over 1 mole of it. And then when we do this, we calculate that we need only 16.57 grams of it. We only need that much, 16.57 grams. Well, how do you know what was left over? Well, if you notice, in the beginning of the problem, we started with 25 grams of the lead-2 nitrate. So 25 grams of lead-2 nitrate minus 16.57 grams of it is going to equal 8.43 grams left over. Okay? So 8.43 grams left over. And if we go back to our equation up here, 16.57 grams of this was needed. Okay? All right. So let's see what else we have to do with this. We had a percent yield of this reaction. We'll calculate that in just 1 second. But we also started with 15 grams of the NaI, okay, and that formed the 8.51 grams of the sodium nitrate. So now for the very last part. If 6 grams of sodium nitrate, and that was a little typo, nitrate, are formed in the reaction described, what is the percent yield of the reaction? Well, percent yield is your actual, you can spell it right, over your theoretical. And our actual happens to be the 6 grams from the problem alone. Okay, the theoretical is what we calculated, and we calculated 8.51 grams of the NaNO3. Okay, and so we put the 8.51 grams down here. Do that multiplication, you get 0.7051. You multiply that by 100. That's going to give you 70.51%. Okay, that's your percent yield. Okay, so now we look like we're following the law of conservation of mass here, and it looks like we had 31 point something. Just going to add this up. 23.06 plus 8.51. That's a 7. That's a 5. That's a 1. That's a 3. So 31.57 grams of product, and 16.57 plus 15 means we have 31.57 grams of reactant. So 31.57 grams of reactant going in, 31.57 grams of product going out. And that is how you work that sheet. Good luck.